Okay, video froze, the camera froze. I'm going to try this again. It says, refer to the region R in the first quadrant enclosed by the x-axis and the graph of this quadrant. So, x-axis and the first quadrant. That's all I care about is the first quadrant. So, my other x-intercept is 2. This is what it looks like just in the first quadrant. We need 4 trapezoids. So, 1, 2, 3. I'm hoping I'm just doing this problem because you did not know what T sub 4 meant. It meant 4 trapezoids. But I'll finish this really quickly. 4 trapezoids. And then this is 2. That's 1 right here. And 1/2 comes with the formula. Each height of each trapezoid is 1/2. And now here are the bases. The trapezoid right here, which is actually not a trapezoid, it's a triangle, but f of 0 plus f of 1/2 plus f of 1/2 plus f of 1, so on. I'm hoping that this is enough and that this helps. The next one people wanted me to do is number 22. Number 22 is not that bad, so I'm glad that I can discuss it really quickly. Number 22, you're going to undo the power rule, but not the way it's written. Maybe for some of us that dt being on top was confusing. So it's 1 to 4. Put the dt right here and put a 1 on top if that's confusing. This is t times t to the 1/2 power. I'm going to undo the power rule, but the way it is, it does not look like a power function. It still doesn't look like a power function. Let's take the denominator and multiply, since the bases are the same, and this is to the 1 power. That ends up being t to the 3/2 power. Lastly, bring it up and rewrite this as the integral from 1 to 4, t to the negative 3/2 dt power. All I've done is rewrite your integrand as a power function, and then you're supposed to undo the power rule. So I'm hoping that's sufficient. People also asked for 28. I know I did 28 for some classes, but not for other classes, so I'm going to do 28 again. You can watch it again. You can fast forward it. So 28. We are not going to be undoing the power rule for 28. So number 28 is not like 22, like the one I just went over. Number 28 is not like, for example, 26. 26, you would have to undo the power rule. Number 28 is not like number 24. Take a look at number 24. If your integrand's 1 over x, then your antiderivative is natural log of x. Same thing with 23. If your integrand is secant squared theta, then your antiderivative is tangent of theta. 28 requires a new method, and it's the third method, and it's the last method, and the last method is called undoing the chain rule. First, you have to convince yourself that this problem is showing that the chain rule was done. Let me remind you what the chain rule is. The chain rule is take the derivative of the inside function, multiply by the derivative of the outside function, and throw back in the inside function. Notice how this is also showing a product of two things, so that's good news. The second good news is I have an inside function. It seems like this is g of x because it's sitting inside sine of x. Your goal is to take these 3 portions, these 3 parts, and make sure you can identify those 3 parts in this integrand somewhere. So I've identified where g of x is. It's right here. G prime of x, if this is g of x, its derivative is negative 2x. I know I don't have a negative 2x, but hey, I have a positive 2x. So this is almost g prime of x, almost. I know it's not exactly, but it's okay. The negative is something that doesn't concern us. So this part is addressed and identified. G prime of x is this product right here. This is g of x. Last thing I need you to identify is what that is. And I'm hoping you realize that that right there is f prime. So this is f prime, and again, g of x is sitting inside f prime like it's supposed to in the chain rule. So if f prime, let's write this down, f prime is sine of x, then let's work backwards and identify that f of x is negative cosine of x. Okay, so here's my antiderivative, negative, I think, question mark, negative cosine of, not x, of 1 minus x squared. Before you go plug in anything in here, before you plug in 1, before you plug in negative 1, can you please confirm that this is the correct antiderivative? Take the derivative of this and confirm that you get 2x times sine of 1 minus x squared. I'll do it with you. And take the derivative of that. Here's a negative. That's just going to stay. The derivative of 1 minus x squared is negative 2x. The derivative of cosine is negative sine, and you throw back in the inside function. These negatives cancel, but I'll still be left with a negative, which is not cool, because my integrand doesn't have a negative. So my final answer is not this, except it's that. And then this is where you would plug in negative 1 and 1 and finish the second fundamental theorem of calculus. This is how you undo the chain rule. It's really hard to show work. Again, I recommend anytime you find the antiderivative, like we found it here, go check go find its derivative to make sure you're correct. I'm going to go on to the next one. A lot of you said 32. I'm a little disappointed that we asked for 32, but I promised that I would do them, so let's do them. Actually, I'm not doing them. I'm just going to talk about it. You know, 32 just makes a semicircle. What do you do with the 2? Pull it out. It's a constant. So the square root of 64, minus x squared, that's just a semicircle above the x-axis, and you're going from negative 8 to 8. Go find the area of the semicircle.